today we are going to do some methods of preparation of aldehydes and ketones. All right. Some of the important methods which are there in your syllabus for the +2 board exams, that is the ISC syllabus. Okay. So what are these methods of preparation? The first method of preparation that we can consider is the preparation of aldehydes and ketones by oxidation of alcohols. So the first method of preparation is by oxidation of alcohols, by the oxidation of alcohols. And this you have been studying from standard 10 that, alkenes get oxidized to alcohols and alcohols in turn get oxidized to carbonyl compounds and further on carboxylic acid and so on. So by the oxidation of alcohols, we will write here. Okay. Now, what is the method? Aldehydes are formed from primary alcohols, by just using any oxidizing agent. So suppose I'm using RCH2OH. This is any alcohol that I am taking. It's a primary alcohol subjected to oxidation in presence of a good oxidizing agent like an acidified potassium dichromate, K2Cr2O7 in presence of H2SO4, and this is going to give us RCHO. RCHO, that is an aldehyde is obtained. All right, ketones can be prepared by, if you're using a secondary alcohol. This is a primary alcohol. If you use a secondary alcohol, like for example, you have C and you have an R here and an R, that these are the two methyl groups. This is a hydrogen and it has attached to an oxygen. So in this case, this is subjected to oxidation using the same oxidizing agent like acidified potassium dichromate, then you are going to get the oxidized product as the ketone, that is RC double bond O and an R. Okay. Now this is one method where your oxidizing agent is used and it is getting converted into the alcohol. The other method by which you can prepare from the alcohols is also by when vapors of primary alcohol are passed over. One more method that we can make use of is when this is by catalytic dehydrogenation. We can write this as catalytic dehydrogenation. Catalytic dehydrogenation. All right. Is it same like the previous one? Kind of, yes. Let me erase this first. All right. So this is dehydrogenation. That is removal of hydrogen in a way. So dehydrogenation of alcohols. I'm not writing. Now, how would you prepare this? It is simple. A primary alcohol, all right, when it is made to pass through or it is passed over heated metallic catalysts such as copper or silver at 573 degree Celsius, then it is going to get oxidized to the aldehyde. So primary alcohol will give us an aldehyde. The reagent in this case, we are going to use copper at a high temperature, let us say 573 Kelvin. Similarly, a secondary alcohol is going to give us a ketone. So a secondary alcohol under the same conditions is going to give us a ketone. All right. So this is one of the other methods of preparation. Now let's come to the third method of preparation here, which is going to be from by ozonolysis. I can write by ozonolysis. By ozonolysis. Now, what is this ozonolysis of alkenes? All right. Now, this ozonolysis of alkenes, you just do the reaction in standard 10 that, okay, an alkene is treated with an ozone. So it forms an ozonite and thereafter it gets converted into the aldehyde or the ketonic group. So the reaction is again not that difficult to remember. It is you take any alkene. Remember the reaction will occur where there is a double bond in the molecule. If there are two double bonds in a molecule, At both the places, the ozonolysis will occur and the corresponding carbonyl compounds are obtained. Okay, so this is it. And let us say this is R, or you can take it as an R dash. When this is treated with ozone, this is treated with ozone in carbon tetrachloride. Okay, when this is treated with ozone in carbon tetrachloride, then the alkene gets oxidized by ozone. All right. Uh, Let us see the diagram here. It's going to be R. Okay. The added oxygen, this is the added oxygen. This I can show you in blue also there. So this is carbon. Okay. And this remains as a hydrogen. The added oxygen is going to be O. All right. And from here again you get an oxygen. So 3 atoms of oxygen have to add up. So it's going to add up, and here you are going to get a carbon, and this is going to be an H, and this is going to be the R dash as it is. All right. Now this compound is called as ozonite. Okay, this compound is called as ozonite. Now these ozonites are highly unstable compounds. All right, they will immediately, the ozonites, they can be immediately reduced by hydrogen on palladium, or, it can be just subjected to hydrolysis when oxygen can be removed. So what kind will be the rupture in the ozonite? Actually, when this is treated with, okay, you can write it down as hydrogen in presence of palladium as the catalyst. I will just show in green where the rupture occurs, and then we can go to the next page to see what will be the products obtained. So the rupture is going to occur like this. Okay, the bond rupture is going to occur like this. So you see, actually one molecule of oxygen will be given out, and these 2 oxygens will remain with the 2 carbon atoms and lead to the formation of a carbonyl group. This bond is also going to rupture. So the bond is going to move this side, and this bond is going to move this side. So let me show you in the next page exactly what is going to happen. So the products obtained will be, in the case of ozonolysis, the product obtained would be, if I have started with the R, so it's going to be R, all right, and then you get a C, then the H remains as it is, and the double bonded oxygen will be obtained. All right. Similarly, the middle oxygen is lost. The other group is also going to be the same. So you get an O double bond C. Okay. That C I can write in red. So this is going to be C, and you have an H. It's not writing. H, and then in that case, H, and this is going to be an R. All right. So you see 2 carbonyl groups are actually obtained, and actually the 2 carbonyl compounds are obtained. So depending upon where the double bond is, the resultant molecules will form the carbonyl compounds at that position. We'll just take a couple of examples here. Let us say we are going to take the case of uh, any compound you want me to take. Like, let me take the case of uh, CH3. Okay, very important that you understand the ozonite and ozonolysis correctly, because the compounds obtained are going to be according to that. So this is C, and let us say this is a hydrogen, and it has a double bond here, and this is going to be CH. Okay. Okay, if it is a double bond, you cannot have an H here, so it's going to be, let me write a CH3 here also, and let me write a CH3 here also. When this is subjected to, it can be written like this: O, ozone, treated with ozone, all right, in, of course, carbon tetrachloride, CCl4 you will write. And the second reaction is, suppose it is given like this, H2 in presence of palladium, then you can directly write the product that will be formed. So the best way to understand ozonolysis is, if you pay attention here, it's going to be very easy for you to remember. The best way to remember is that in the process of ozonolysis, the molecule is actually going to rupture from here. Both the bonds will rupture, but it is not that the sp2 hybridized carbon becomes sp3 hybridized or anything. The two bonds will remain as they are, and the compound that you will get in this case is, if I look at this part of the compound, if I look at this part of the compound, then it is going to form CH3, all right, a C and an H and the double bond O. So this part of the molecule is going to be like this. However, if I look at the other part of the molecule, all right, let us say I look at this part of the molecule. Now this part of the molecule is going to form a compound, which if I write it in the same way as it is written, then I can actually write, okay, I can actually write this part here as O double bond C, and it's going to have a methyl group here and a methyl group here. So you see the two carbonyl compounds that I got were, this is ethanal. The compound that I get here is ethanal, all right, and the compound that I get on the other side is actually acetone. Now, just by looking at the position of the double bond in the molecule, we can actually immediately say what are the carbonyl compounds that will be formed. So like I said, if there are more than one double bonds, obviously both the double bonds will undergo the process of ozonolysis. One of the other examples that you can take in this case is that of benzene. All right, benzene is like this: 1, 2, 3, 4, 5, and 6. So you have a benzene molecule like this. You see, it is having double bonds at 3 places. So all these places we can undergo the rupture. So if I have to show ozonolysis in this case, remember what will happen. The molecule is going to rupture from here. It's going to rupture from here. It's going to rupture from here. All these places are carbon, carbon, carbon. So this is a carbon. So I'm just showing the carbon so that it becomes easier for us to know what will be the products obtained. So when this is subjected to ozonolysis, that is the rupture is occurring, and of course it is followed by H2 and palladium. Then what we find that the molecule is breaking. So if I actually show you this part of the molecule, then it is going to be like C. Okay, let me write that in red. It's going to be C, all right, and a C. Since this part has ruptured, it's going to be an oxygen here. This is going to be an oxygen here. Remember, each carbon is also attached to one more hydrogen. So you are basically getting diethanal, like, the two aldehyde groups are here. All right. Okay. Then how many such kind of molecules we'll get? All the 3 positions you will get the same kind of a molecule. So the compound obtained is going to be 3 of these kinds. So wherever is the double bond, the ozonolysis is going to take place there. You can just rupture, show the rupture of the bond and just place the oxygens in those positions, and therefore you know that the 2 carbonyl groups will be obtained. This is a very important method for preparing the carbonyl compounds by this method. Okay. Now coming next to what is the other method by which we can prepare? The next method is by preparation from alkynes. So if I write this as from alkynes, let us see how many numbers we have done so far. So we have done 1, 2, 3 methods. So this is going to be the 4th one. So in the 4th method, we are going to do it by from alkynes, or let me write it like all from alkynes. This is not here. Okay, so here we go. Here we go. This is 4th and from alkynes. From alkynes. All right. Now depends on what kind of alkynes we take. Suppose I'm going to take R, C, triple bond, and then C and then H. So this is an alkyne I'm taking. When this is subjected to treatment, all right, when or passing vapors of alkynes through 42% sulfuric acid, if you're taking through 42% sulfuric acid in the presence of a catalyst like mercuric sulfate at 333 Kelvin, then it gets converted to ketones. Now what happens in this case is, you see, this is, I'm going to just write 40% H2SO4. Okay, 40% H2SO4, and in presence of HgSO4, that is mercuric sulfate. Okay, what I'm going to get here in this case is R, all right, C, then the double bond is there, and this is CH2, okay, and this is going to be an OH. Now, actually, if you look at it, this is just the enol that has been formed, the carbon with the double bond, and you have a hydroxy group. So, a kind of an enol is formed. Now, this enol will undergo tautomerism. Actually, it is that is one phenomena that you study under isomerism, and it's going to change to that, whereby the H will move here, all right, and the double bond is going to move here. So, what you are going to get is an R, C, double bond O, and a CH3. Okay, this is a more stable form of the keto-enol tautomerism, where the keto compounds are considered to be more stable, and that is why it gets, tautomerized to this form, or this is formed. Now what happens when you take the simplest of the alkynes, that is ethyne? So when you take ethyne, in that same case again, if you are talking about ethyne, it is C, I mean there is a hydrogen triple bond and a hydrogen Okay, children, by mistake, I did not unmute. So that is why that part was left out. So I'll have to go back to this again. So we were doing this part, and I was explaining that, like, how from alkynes it can be obtained. So this part I have explained already, and it forms an enol, and the enol form is going to tautomerize immediately to form the ketone. All right. So I think you'll have to go back to this page to understand what I was talking there. And then, of course, you have the ethine, the simplest of the alkyne, that is the ethine, which is getting converted to ethanol. So carbonyl compound like ethanol will be obtained in this case. The next page that we have to talk about is by dry distillation of calcium salts of carboxylic acids. Now there are three ways that you have to do it. If you look at this, the first method, we are taking only the um, calcium formate. All right, this is calcium formate because the formate ion is there, but though the calcium ion is written afterwards, but the way you call it, it's according to the rules, it's going to be calcium formate. So when this is dry distilled, actually you are getting HC double bond O and an H. You can understand why, because see, in the second step here, in this step here, if you look at this one, this is the molecule of calcium formate. This is a molecule of calcium formate. So when calcium carbonate is given out, then it is going to form HCO and an H. So you get a formaldehyde here. Plus, if you take a mixture of, let's go back to this. If you take a mixture of calcium formate and you take a mixture of calcium acetate, all right, then what do you see? That of course you are going to get an ethanol. All right, the compound that is underlined especially is the ethanol. This is what you're going to get, ethanol. Though we cannot rule out the possibility of the formation of formaldehyde or the formation of the ketone. Why I am talking about ketone is, if you go to the third one, that is here, where we have just taken calcium acetate only. So when I'm taking only calcium acetate and it is subjected to dry distillation, then what we are getting is an acetone. So this is CH3CO and a CH3. So when this is CH3CO, CH3, the possibility of the formation of this compound is also there in this case. So what we are saying is that by distillation of calcium salts, if I'm taking only calcium formate, then I'm getting only formaldehyde. If I'm taking only calcium acetate, I'm getting acetone. But yes, if I have to prepare an aldehyde, then in that case, if I'm taking a mixture, then the possibility of the other compounds cannot be ruled out. So that is one more way given here. All right. Now there are a couple of reactions which are meant only for the preparation of aldehydes, and there are certain reactions which are meant only for the preparation of ketones, out of which one or two we can do here. So let's go to that. So if I go to the sixth method, whereby which we are going to prepare only the aldehydes. So this can be done by the help of Rosenmund reduction. Rosenmund reduction. All right, Rosenmund reduction. Now, what is this all about? You have to take an RCOCl, that is acetyl chloride. Okay, this is an RCOCl, that's an acetyl chloride. It is treated with H2. It is treated with H2 and it is supported over the catalyst palladium, supported over barium sulfate. Okay, and the reagent is, it's going to be in presence of boiling xylene. All right. When this happens, it gets reduced to RCHO. Now, since RCOCl is the COCl is a terminal group, obviously it will be able to form only the aldehydes, and it will not form in the ketones, because for the ketones that RCOCl group is not available. This is a terminal group, and therefore in presence of palladium supported over barium sulfate, if the acid chloride is treated with hydrogen in presence of boiling xylene, which is used as the solvent, then it gets converted into an acetaldehyde. So this is one of the methods by which you can prepare aldehydes only. On the other hand, if you want to prepare ketones from acid chloride, then the other way that you can use is actually for, let me make this as the seventh one. So if you are using RCOCl to obtain ketones, then the reagent has to change. You have to treat this with an organometallic compound, that is organocadmium chloride. All right, and in by this it can be converted into R, C double bond O and then R. That is, a ketone can be obtained plus a cadmium chloride can be given out. You see, in this case, what is going to happen? R or R dash I can write here. If this is an R dash I'm using, so the cadmium is going to pull out this chlorine. So this has to be cadmium chloride. Okay, so it's going to be cadmium chloride. All right, and of course the ketone will be obtained. So these are some of the methods by which we can prepare. There is one more method is there, in which case we can prepare it from RCN, sorry, that is all right, RCN, when this is treated with R dash MgX, that's an Grignard's reagent, we know that this is going to attack the this carbon, which is del positive. All right, and of course the addition compound is going to be R. You have a C and an R dash. Okay, and you have a doubly bonded N, because one of the bonds has opened up, and to this side it is going to have MgX. It's going to have MgX. All right, and then this can be further converted to, or further hydrolyzed to, can be further hydrolyzed to, MgX will go with OH, and therefore what you will get in this case is ammonia. So let me write the compound here. You are going to get an R, a C, R dash. Okay, this will not write here. R dash, and you get a, in this case, double bond oxygen, plus you will get ammonia. All right, and plus you will get MgXOH. MgXOH. This is the usual course of steps that are involved when a Grignard reagent adds up to any, whether it is a C double bond O or whether it is C triple bond N, the process is almost the same. So that was about the methods of preparation of aldehydes and ketones. Now let us see what is there. So I'll just take a screenshot of this, and that's all, I think. Methods of preparation. So quickly, let us just go through this. This is the method of preparation of aldehydes and ketones that we have done. So the first method was by the oxidation of alcohols and primary, and this was the secondary alcohol that we discussed. That is going to give us a ketone, and this is going to give us an aldehyde. So just a quick revision, and then I can let you go. Then the next is a catalytic dehydration of alcohols. Basically, it is the same. The primary alcohol, when it is passed over a heated metal like copper and 573 Kelvin temperature, you get an aldehyde and you get a ketone. Third method, which is a very important one, is by ozonolysis. So this is an important method, and just remember that in the case of ozonolysis, at the double bond, the molecule is going to rupture to give rise to carbonyl compounds. Okay, and in the next page we did that in a little detailed way. So this is how it happens, and we also tried out for the benzene. So the molecule is here. One more thing I can explain here is that suppose you have been given two carbonyl compounds. Okay, let us say the question, and acetone was obtained when a compound A was subjected to ozonolysis. So what was that compound A? All you need to do to find out that compound is, you can take HC double bond O, and it says formaldehyde, and it said what was the other compound? Acetone. So you can write down this like this. See, it's very easy to know the position of the double bond. Just, this is the place where the double bond was actually there. So you remove that O from there and you write down the structure of the compound, and you will be able to identify the compound. So it's going to be CH3 and the CH3. So if you know where the double bond is, you know what the carbonyl compounds will be. And if the question says that these are the carbonyl compounds that you have got, then you will be able to tell the original compound also. So this is that what we did in ozonolysis. Then the next we'll go to ozonolysis. Then of course we did this for the benzene, and that is it. Then this we did for the alkynes. In the case of alkynes, uh, what happens is, in the case of alkynes, it is subjected to H2SO4 and HeSO4. This is basically an addition of water molecule according to the Markovnikov's addition. It is actually adding up. You see, the positive part of the reagent is taking up, is going to carbon containing more number of hydrogen. And in the other case, it is the OH is adding up here. I hope you remember Markovnikov's addition. This is what Markovnikov's addition is occurring. The positive part of the water molecule is adding up to the terminal carbon, which is having one hydrogen. Remember, this carbon does not have a hydrogen. This carbon does not have a hydrogen. So anyway, in this case, the hydrogen is adding up here. So you get a CH2 and OH. Now this is an enolic form, and this molecule will immediately rearrange, or it will undergo the tautomerization to form the, the H will move here. All right. So this is actually CH2 here when it is adding up. Okay. This is actually CH2. I don't know, it got erased or what. So this is CH2. So this goes here, and of course you get a CH3, and the ketone is obtained. Okay. And if you are taking up the simplest of the alkyne, that is ethane, the same thing will happen in that case also. In this case, that Markovnikov's addition does not have any importance, because it's a symmetrical alkyne, and any one of it is going to take the H. So the intermediate compound is going to be H, then a C, then an H, double bond, then you have an OH and an H, and then this is going to get, this is going to be an H, and then this H is going to get transferred this side, and this compound will be obtained. So that was about it. So little things that you need to pay attention to. Then the next one that we did was by distillation of calcium salts of carboxylic acids. So this also we have done, and of course, I hope you all have understood this part also. In details, we have done this also. And of course, the next part was the Rosenmund reduction for preparation of aldehydes. And of course, if you are using organometallic compound like cadmium chloride, organocadmium chloride, then you are going to get a ketone also. And the last one that we did was the addition of a Grignard's reagent. So basically, all the methods we have almost touched, and hope that is enough for the methods of preparation of aldehydes and ketones. So I think we'll end up here, and in between the video does not have any sound because I muted that and forgot to unmute that. Anyway, that part I have revised also. So hope things are okay. So that's all now. And I think I'll end the class here.